Okay, so you've already looked at one word problem, but I would just want to do a few more just so that you can get the hang of how these work. So let's continue on and look at a few more word problems. Let's start with a flagpole. So we have a flagpole, it sways back and forth in high winds. The top sways 10 centimeters to the right, which is plus 10, and 10 centimeters to the left, which is negative 10 from its vertical position. From its rest position, it begins moving to the right and moves back and forth 20 times per minute. Write an equation to represent the distance of the top of the pole from its vertical position in terms of time. So whenever I'm doing these types of word problems, I always like to kind of draw what's happening just so that I have a better idea when I go to create my equation. So it tells me that it when it moves to the right, it's at a plus 10. When it moves to the left, it's at a negative 10. It also tells me 20 times per minute. So I need to figure out how long one cycle occurs. So I'm going to take 60. There's 60 seconds in a minute, divide it by 20, which means a cycle occurs every 3 seconds. So let's put a 3 here. And now I'll break up my graph to help me plot my points. 2.25. So I do that just by, I take half of 3, which is 1.5, then I take half of 1.5, which is 0.75, and then I add 0.75 on the other side of 1.5. So I break it up. Now it tells me it starts from its rest position. So rest position is here, and then it goes to the right, back to the rest, down to the left, back to the rest. So we have a function that looks like this. Now, the reason why I do this is because then it becomes easier for me to see what my different values are going to be. So for example, my amplitude, I can take my max minus my min and figure out my amplitude and divide by 2. But I can just see from looking here on my graph that it has an amplitude of 10. My period is 3 seconds, but to figure out what I'm going to put into my equation, I have to put that equal to 360 over b. From there, I cross multiply it. Let's cross multiply this. Same thing over 1. So I get 3b equals 360. Divide by 3 and divide by 3. So 120 is going to be the number we're going to use in our equation. C is our sinusoidal axis. Well, I can see that this function has not been moved up or down. My sinusoidal axis is right here at 0. So 0. And then the last thing is D. Now, D, remember, is your phase shift. And your phase shift will depend on what kind of equation you're going to write. And it didn't tell us if we have to write a sine equation or a cosine equation. We're going to go back to our graph. We're going to look. And I can see that this looks like a sine graph to me. It starts at 0, 0, goes up, then it goes down, and then back. So if I use sine, then there is no phase shift. So let me write this. H of t equals my amplitude, which was 10, sine 120, which is the period, t. And I don't have to add anything here on the end because there is no sinusoidal axis, so I didn't have to add something, but there is no phase shift either, so it stays this way. Now, let's say you're somebody who always likes to write cosine functions. So cosine would begin at a max, go down, and then back up. So I would then have to take into consideration where it starts on that max. And in this case, then, we do have that phase shift of 0.75. So if I was going to write my cosine function, notice that my amplitude and the period all stay the same. Same with the sinusoidal axis, but it's my phase shift that changes. There we go. And so we have to make sure that, oops, that's not sine. Sorry, cos. That if we decide to write our function, we have to take a look at where it begins in terms of cos or sine. Sorry about that. Okay. Predator-prey population. So suppose the number n of prey in a given area can be modeled by the function n of t equals 250 sine 90t plus 500, where t is the number of years since a base year. So base year, that means that's where they're starting at, 1990. So what was the population of prey in 1990? So that means time is equal to 0. So there's a couple of ways you can solve this. You could graph the situation, which totally works, and then just take a look. Or we can actually sub in that value 0 into our function, just like this. So where there was a t, I replaced it with a 0. And 90 times 0 is 0. And you can put this directly into your calculator, but it's really not necessary. Sine of 0 is 0, and 250 times 0 is 0, so 500. So this equals out to, there was 500 prey in the year 1990. Part B says, what is the maximum population of the prey and where does it occur? So the maximum population of the prey comes from, we can always find our max by, if we know our C value, right? So let me just kind of draw a graph here. We know our C value is at 500. That's our sinusoidal axis. And then if we put in our amplitude, so our amplitude is 250. So 750, and then this would be down at 250. So if we go C plus A, or in this case, C plus 250, we get 750. So we can see that that's going to be our max. Whoops. So that's C plus A will give us our max. This we know started at 500. 500. If I go into my function, it has a 90 here. So 360 divided by 90 equals 4. 4, 2, 1, 3, which means if it starts here, it goes up and back to 2 and down. So it looks like this. So the maximum we can see is right here at 1, after 1 year. So our max is 750 prey at year 1991. All right. Well, let's take a look at one more problem. This one's kind of a doozy. So we have this Ferris wheel. It was being built in 2009. It was supposed to happen in 2010. I don't think it's ever been built. If I recall, the last time I looked it up, it still was not finished. But anyways, we're going to use this to help us out. So the max height is 208 meters. One revolution takes 37 minutes. So to go the whole way around takes 37 minutes. Diameter is approximately 198 meters. You get 3 revolutions per trip. So riders can see the Great Wall of China if they are at least 200 meters above the ground. If a rider gets on at a height of 10 meters above the ground at time equals 0 minutes, determine the time interval when the rider can see the Great Wall of China during the trip. So this is what we're trying to figure out. When can they see the Great Wall of China? So I'm actually going to start with a graph. I need a graph in order to help me figure out my equation. Whoops. So let me just steal this here, I think. There we go. And copy it. And let's go to the next page. And paste. Okay. This is all the information that I need. All right, so we get on at 10 and it has a total height of 208, which means the distance between here and here is 198. So if I want to figure out my C value, I want to find the average in between here and here. So if I go max plus min divided by 2, I get 208 plus 10 divided by 2, so 218 divided by 2, which is 109. So my halfway mark right here is at 109. And I'm just going to put a dotted line across because that's my sinusoidal axis. Now my amplitude, of course, is max minus min divided by 2. And so 208 minus 10 divided by 2 is 198 divided by 2, which is 99. So that tells me my amplitude. It takes 37 minutes. So let me go here. 37 minutes, which means, oh, why did they pick such a terrible number? 37 divided by 2 is going to be 18.5. And then 18.5 divided by 2 is 9.25 minutes. And then 18.5 plus 9.25 equals 27.25. Okay. 27.75. Sorry. 27.75. Okay, so let me go. You start here at the 10, and then you're up to here, and then halfway mark, you're at the top height, and then you're back there, and then you're back to the 10, and then you start to repeat yourself. Okay, so it looks something like that. So I have my C value, I figured that out. I have my A value, I figured that out. Next, I need my B value. So my B value is going to be 360 divided by 37. That gives me a decimal, so I think I'm just going to leave it as a fraction so I can have the exactness of it. So let's leave it like that. And then next is D. D is my phase shift. So I got to kind of figure out what kind of an equation I want to write. And I think since it starts low, goes high, and low, this looks like a reversed cosine, right? Cosine starts high, goes low, goes high. But this starts at the negative. So I'm going to do a negative cosine graph. And if I do, then I don't have a phase shift, which is lovely. So I'm going to lose a phase shift. So my height, h of t, is equal to my negative. Okay, so amplitude is 99. Cos, I'm doing a cos here. My period is 360 over 37t. And then my sinusoidal axis is 109. There we go. Oh, wow. Okay, so now we need to figure when can we see the Great Wall of China? So I have my equation. I can see the Great Wall of China when it is at least 200 feet. So 200 feet's like here. So whenever we're above the 200 feet, so it's like this part up here. All right, that means I need to figure out a couple of spots on my graph. So to do that, my height is 200. I'm going to input this into my equation. Whoops. And I'm going to solve for t. So this takes a little bit of work here. Solving equations, I'm going to start by subtracting the 109, which gives me 91. Okay, and then I'm going to actually change my view so I can see this a little bit bigger. Oh, humongous. Then I'm going to divide by a negative 99 each side. Okay, 91 divided by a negative 99 gives me negative 0.91919191, and so on. I'm going to keep a whole bunch of decimal places. That will help. Okay. Cos 360 over 37. So we're getting there. Now I want to get rid of the cos. Remember, to get rid of a cos, we got to do the inverse. So cos inverse. But of course, what I do to one side, I have to do to the other side. These will cancel, which is great, leaving me with 360 over 37t. And over here, I want to go shift cos of that answer, and I get 157. All right. Next, I want to get rid of this 360 divided by 37. So the 360 is being multiplied, the 337 is being divided. If I actually just flip that fraction and multiply to it, notice 37 then cancels with 37 and 360 cancels with 360. But if I'm going to do that on one side, I have to do it on the other side. And so now 337 times 157 equals, divided by 360. Oops, I hit something wrong in my calculator. 37 times 157 equals, divided by 360, and I get 16.1. 0.1 equals t. All right. Well, that gives me part of my answer. That gives me, let's do this in red. Not a very straight line, but it gives me that point right there, right at the 200 mark. It tells me that it's at 16.1. Now I do know my top is at 18.5, and I can actually use that to help me figure out this next spot over on the other side. So if I go 18.5 minus 18.5 minus 16.1, I get 2.4. So if it's 2.4 time-wise to go to half of it, then the other half would be another 2.4. So if I add another 2.4, I get 20.9, which means my first interval is going to be 16.1 to 20.9. So that's my first time interval where I can see the Great Wall of China. Now I'm actually going to do 3 rotations, right? So I'm going to get on this Ferris wheel and I'm going to go up and I'm going to go down, and then I'm going to continue right up and then down 3 times. So I don't want to have to try to figure this out with my equation. Instead, we can use the fact that because this is periodic and everything repeats itself, since it occurs every 37 minutes, I can just add 37 to both these times. So 16.1 plus 37, and I get 53.1 and 57.9. And that would be the second time interval that I would get a chance to see the Great Wall of China. And then if I do the same thing again, I add another 37 minutes and I add another 37 minutes. Then I have 90.1 for this interval and 94.9 for that interval. And then these are the 3. This is the first time I see the Great Wall of China. This would be the second rotation where I see the Great Wall of China. And this would be the third rotation where I see the Great Wall of China. All right. So let me just change the view here for a minute so we can kind of look at everything. So as you can see, there was a whole lot to this question, right? But we can use the graph, use what we have in order to see, in order to help us come up with an equation, in order for us to figure out, because it's periodic, those other time intervals. All right, so good luck. Try some questions on your own and feel free to reach out if you have any problems.